exponential functions. Linear functions we've been working on all year. Hopefully we're at least moderately comfortable with those by now, okay? So today, like I said, we're gonna practice those exponential functions. So I've got a bunch of tables here, okay? And we're gonna look at the tables. Let's start easy. Let's start with this one that doesn't have any fractions with it, okay? So first thing we have to make sure is that our x's are going up by 1. Our inputs are going up by 1, because if not, we have a little bit extra work to do at the end. So looking at this guy, each of these numbers are going up by 1. We're good to go. We got -2, -1, 0, 1, 2. Awesome. We also have to make sure that 0 is one of our values, because if not, we have a little extra work to do again. And we're actually going to talk about that extra work stuff when I see you guys on Wednesday. So looking at y's here, we want to find what the common multiple or divisor is. So looking right here, 2 to 4, well, that looks like it's going to be a times 2. But let's check all those out. 4 to 8 is times 2. 8 to 16 is times 2. And 16 to 32 is also times 2. So we're adding 1 repeatedly. We have a times 2 as a factor, okay? And we're going to write our function, y equals or f of x equals, okay, in this, using these numbers. So y equals, our common multiple is 2. So we're going to have a 2 to the x, okay, because the common multiple, or b, remember our generic form was y equals a times b to the x. Okay, we went over that last time. So b here is 2. Where we get a from is what the y coordinate is when x equals 0. That's just our x-intercept, or our location that we begin. Our location that we begin at is 8. So our function here is going to be 8 times 2 to the x. And that's it. Okay? Any questions on the first example, guys? All right. Let's backtrack to one of these fraction ones, okay? Looking at the fraction ones, these might be hard to see what the common multiple is. However, we have 2 integers here that we can work with. First thing we have to make sure is that we're going up by 1s, which looking at those x's, we are. That's good to go. Second thing we have to make sure is that we have x equals 0, which we do. Now, looking at the 2 integers, it looks like this is times 6, okay? 2 times 2 to 12 is times 6. Just to verify, is 1/3 times 6 2, or is 6/3 2? Well, that case it is. And if we check all these other multiples, we'd get times 6 for all of them. Okay, so writing our equation here, our multiple is 6, so we're going to get a 6 to the x. That's our b piece of this function. And our initial value is 1/3. So we'd have 1/3 times 6 to the x. Okay. Any questions on that at all, guys?
Wait, so how do we start? Like, what's the
we have to double check some things first, then we got to find the common multiple and the initial value. So we just need 2 numbers here. Okay, so I'll do a few more just to reiterate for you. Okay, so looking at this, we got to check that our x's are going up by 1s, which they are. That's good to go. We also have to check that we have the y value when x is 0, which we do have right here. So those are 2 checks we have to check for. Next thing we got to do is we got to check our y's and find what it's going up by, what multiple it's going up by. I see 2 integers. Those are usually the easiest ones to use. Okay, to get from 1 to 6, I have to times by 6. We know that we're multiplying or dividing because we're talking about exponential functions here. Okay, so times 6 to get from 1 to 6, we're going up by 1s. We have our initial value. We can write our function. Our initial value here is 1/6. We know that because that's what the y is when x is 0. So we're going to have 1/6 as our initial. And then we're going up by 6 repeatedly. So we're going to multiply 1/6 by 6 to the x. So like 6 is kind of like the slope, but in a different context. Okay. 1/6 is the y-intercept or the b value, but in this formula, it has a different name. All right, let's move on to what happens when it gets smaller, because it's not always going to get bigger. We see it getting bigger here. This is called exponential growth. What happens when we're getting smaller? Exponential decay. What's up, David? Do you have a question in the chat?
Is there going to be is there a video for this?
This is going to be the video I'm going to post, but I can get you another video if this one doesn't do.
Okay, because I just want to make sure I remember this because it's kind of confusing.
Yeah, I'm going to post this one right after class.
Cool.
All right. So next one, we're getting smaller in this case. So this one's a little bit different. We're getting smaller. We're dividing. First thing we're going to check is that we're going up by 1 every single time. -2, -1, 0, 1, 2. We are adding 1, so that's good to go. Second thing we have to check is that we have x equals 0 in our table, which we do. That whole row is the x value at 0 and the y value when x is 0. Okay, now we want to find what we're dividing by. We're clearly dividing as we get bigger here. -12 to 2 to this to this to this. We're getting into smaller and smaller fractions, right? So how do I get from -12 to -2? Well, I divide by 6. Okay, in theory, I add 10, but we know we're talking about exponential, so we're either multiplying or dividing. So we're dividing by 6. -2 to -1/3, well, that's a divide by 6 as well. And as I go on and on and on, I'm dividing by 6 over and over and over again. So how do we write this as our function? So we're still starting with our initial value. When x is 0, the y is -1/3. That's our initial value. We write that first, just like we did in the other 3 problems we've gone over, okay? When dividing by 6, exponentials are always multiplication. So dividing by 6 is the same as multiplying by what? Does anybody remember?
One-sixth.
1/6, good. Dividing by 6 is the same as multiplying by 1/6. So in my formula, the b value isn't divided by 6, it's times 1/6 to the x. So it's still our common multiple over and over and over again, but this time it is just a fraction. Okay, we're gonna go over, I can go over the rest of the 4 problems I have just so that we're comfortable, and I assigned you guys 6 to practice on your own, okay? All right, number 11. Are we going up by ones? We sure are. -2, -1, 0, 1, 2. Those are all going up by ones. We have when x is 0, so we don't have to do any extra work there. I see some fractions. I'm going to just skip ahead to the integers because it's usually easier to tell a multiple in the integers. To get from -2 to -10, I'm multiplying by 5. To get from -10 to -50, I'm multiplying by 5. So I have my initial value. I have my common multiple. My function's going to be the initial value, which is -2, times our common multiple is 5 to the x. Okay. Next one, x values going up by 1. Good to go. We have our initial value of -3. I have fractions. I'm just going to skip ahead to my integers. To get from -3 to -24, what am I multiplying by? Well, I'm multiplying by 8. Okay. -24 to -192, if you divide the bigger by the smaller, you'll get that you're multiplying by 8. Okay, so we have our common multiple, we have our initial value, our function's going to be the initial value, which is -3. We get that right here. The x value is 0, this is your initial value. Common multiple is 8, so times 8 to the x. Any questions on that? Okay. We got 3 more. Okay, looking at number 13, we're getting smaller again, right? We're starting at -64 and we end up as a fraction, a pretty small fraction at that. First thing to check, we're going up by ones. Second thing to check, we have our 0 x value. So let's look at the integers. To get from -64 to -8, I'm dividing, I'm getting smaller, and I'm getting smaller by a factor divided by 8. Same thing happens here, we can validate that. Divide by 8 to get from -8 to -1. Divide by 8 to get from -1 to -1/8, right? 1 divided by 8 is 1/8. And that continues forever. So we're not going to write divide by 8. Remember what we saw above, okay? When we're dividing by 8, our common factor is 1/8, okay? So my function's going to be initial value of -1. Common multiple, 1/8. So times 1/8 to the x. We got to make sure to put that 1/8 in parentheses. That way the whole 1/8 is being raised to the x, okay? Any questions on that problem, guys?
Nope.
All right, we got 2 more. This one's getting bigger again. We love that. Going up by ones, we're good. We got 0, we're good. Okay, and you have to make sure that all of them are going up by ones, which they are. They're all the same values for this practice. Okay, let's look at our integers right here. To get from -3 to -18, I'm multiplying by 6. Half times 6 is -3, or -half times 6 is -3. That's just a valuation with the fractions. We have our initial value of -half. That's when x is 0. We have our common multiple of 6 raised to the x. Okay, we got one last one, and then I'm talking at you. Okay, going up by ones all the way across the board. Good to go. We have our y when x is 0. Good to go. And our common multiple, we're getting smaller again. Okay, smaller across the board. Easiest to see the answer from -12 to -2, in my opinion. To get from -12 to -2, dividing by 6. That goes all the way across the board. And remember, when we divide, that's the same as multiplying by the fraction or the reciprocal. So divide by 6 is the same as multiplying by 1/6. So we have initial value of -2 times 1/6 to the x. 1/6 is our common multiple.